Okay, so before the break, looked at quickly at the syntax for exception handling. Next thing for tonight is something that's very important with our software, some sort of persistent data. And on Thursday, we're going to look at that more with uh, internet controlling a MySQL database from our Java program. So we'll look at that. So which is kind of a much better way to store our data than in a text file. Tonight, we're going to look at text and binary files, mostly text files. They're where it's still human readable. I guess we'll do at least one binary file quickly. Um, it's fairly straightforward. Um, Text file, we can, as far as class goes, we're going to look at a couple other things, but as far as class goes, in general, text files in here, we can use the print writer, which is a really easy way for making a text file. It doesn't have it's not as good as some of the other ways, but we'll see that it's quick and easy to write with a print writer and read with a scanner. The big nice thing about print writer is, you know how since basically day one we've been doing that system.out print stuff, print line, print F. There's a whole bunch of them, but print writer has all of the same methods. So that makes it nice and easy for a classroom. Just like system.out, only we say print write, we make an instance of it and printwriter.println or printwriter.printf and do all the formatting syntax. It's quick and easy to work with, and then a scanner just reads stuff so we can read from the file with a scanner the same as we can read from the keyboard. So that's probably what we'll do for class. We need to worry about serialization. Our objects exist in memory and the RAM chip, which the RAM chip may not be super organized with our object, right? It could be in one place, it could be scattered all over the place. In order to put it in a file, we most definitely need it to be in one place and in a certain order. And so we need to turn it to serialize it. We need to serialize the data. Kind of like serial communication, just one long serial communication is the one wire connecting things. We need to make just one long string of the bits that make up our data in a particular order. So we need to make sure that can happen. Terms you might see on a quiz: serialization writes an object to storage, and deserialization writes what's in storage to an object. Probably no surprises there. Then we'll look briefly at some of the better ways. You might be familiar with the word stream. Have you heard that before? Some sort of streaming. That's named after Java. That's named after something in Java. In particular, it's named after input and output streams. I guess the one we talk about would be an output stream, or really it would be a buffered output stream. But we get much more control than we would with there's lots and lots of different ways. We'll kind of look at those, but for class, we'll probably mostly use print writer, which is the one that has the same methods as that system.out. Makes it nice and easy. It's not the most efficient. If we have lots of data, it can start to get really, really slow, noticeably slow, like at time scale humans notice, like, hey, this is taking a long time. Like when we write to the console, do that. I made in a program over the break between the summer and fall semester. I was doing some stuff, some modeling in Blender, and it did not have a noise generation that was going to work for what I was going to do, and I'd have to spend like many hours adjusting the meshes. But I knew that it should have been something that could be done from a noise generation. I just made my own noise generator, and what was I making? 1,000 by 24 images by 1,000 images. Instead of random seed generated, and it was using nonlinear dynamics, some common things from that. But just random noise to adjust graphical patterns. You think of it like white noise, but it was very, very specific white noise. It wasn't randomized white noise. It was highly controlled white noise, and then turn that into Berlin, which like smooths out transitions, or Voronoi, which creates a cellular looking structure. Seems more natural. It takes a grid and then bends, adjust all the points in certain ways so that it looks more like natural cellular structure. So I made those, and while debugging it, I would periodically have to print things out to the screen. In general, ultimately, they were going to an API that could just call for Blender, right? It's on the internet, and if I need that noise, I just write a little script in Blender that just grabs it off the internet. But while debugging it, so we went to files, and it would be super quick. These 1024 by 1024 images. What's 1024 squared? 1024 squared is 1,048,576 points in that image. Each one had a different grayscale with a large calculation to it. What I did three different equations to generate them, and then I generated 5 different types of noise from the white noise that made, and it would write all 5 files, write all that stuff, all 5 files in a couple of milliseconds, possibly nanoseconds. Right? It was as soon as I hit run, it was like immediately the word "finish" popped up on the screen. Quicker than I could tell. But while debugging it, if I needed to print it to the console, it usually didn't even finish printing out before I figured out what it was and stopped it. We're talking like 4 or 5 minutes. That's the difference between sending something to a file in a good way and sending it to the console. And print writer is kind of like sending it to the console. It's not a good way to get to the file, so it's like the difference between a few milliseconds and 4 or 5 minutes. When your data set gets large, like 1,000 data points, or a million data, just over 1 million data points, like that example I was just talking about. So those others can be important because Java is for big projects, enterprise scale, things like Humana, right, where you've got 50,000 employees handling 10 million customers daily, and they all need access to the database at the same time. All want access to the database at the same time. There's lots and lots of stuff going on, so those extra milliseconds add up quickly. So we need to worry about that training stuff. But for the classroom, we'll mostly do the easy one. We're talking about straight, so we just need to be aware of that other stuff. Otherwise, syntax stuff. So let's, I guess, go create one. Just look at this stuff. It's an active subject. We learn by doing, right? Following along the example. So I'm making a new application here. I'll give it a name because I forgot to do the first time and actually had to create an instance of it. File. So our file in help, we're going to create the main class. That way, if for some reason we need to create an instance of it, it's not a really weird object name like we had that first time, where it was like Java project something. It was kind of hard to type. So what did I do in the example? First thing I did was, right to print writer. So print writer is easy. Have we talked about the new comments before I remove this? Okay. Making sure everybody knows under IDE and under IDE tools. There. One of these things here that actually prints out a to-do list full of links that you can get to any line in your project, and that's part of the language. So / single line start with capital to do should work in any IDE and a lot of text editors. I've never sat down and done an extensive list. I use Sublime because Sublime knows it, but I don't know what all text editors do or do not know that. But any nice IDEs would definitely have that functionality because it's part of the language. It's not just something in the IDE. And Java, it does capital to do. If you haven't seen it in Python, it's a comment and then the at symbol to do in lowercase. But most IDEs, Python's an afterthought, so most IDEs can't handle that. But you do, if you know about it. So we need a string to put in the file. String, I'll call it S1, is a new, is going to be assigned a new string value, and the new string, here is a string to write to a file. Not feeling very creative today, but there's a string we can write to a file. So we need the file that it's going to write to, and that's a common type that we will use over and over and over again. I'm going to go ahead and create it here. File, string file is a new file. And then we need, where are we writing it to? String file 1.txt. That looks like a good name for it. I'm just going to put it here. So with no extra addressing, obviously in general, it's probably best to do the absolute addressing, especially in Java, because you're probably running on a server, which means it's going to be very restricted what folders you can and cannot write to. So you're usually going to use absolute addressing, but let me show you where it puts it with the project files. Again, we need to import that, so Control-Shift-I and NetBeans, and we have that file type of data. And then I already said what it was, so let's go and create it. Print writer. These are the objects that have the same methods that you're used to from system.out. Print line, printf are the three that get used most often, but not the only three that are in there. Print writer objects, I'll call it PW, is a new print writer. It's pretty good fix. Oops, space, control space. And oh, that's not what I'm right, control space. Notice when the little documentation pops up, I was expecting it to show something there. Okay, it doesn't seem to show the thing I was looking for. A print writer needs to know where it's writing to. So we want to write to that string file. Obviously the imports, but now we got a whole new error. I'll bring you that message. This is the checked exceptions. The compiler does know about certain things. It's like, oh, you're trying to write to a file. I'm just a Java compiler. I don't know if that file exists or not. It's not safe to just assume that it does. So, unreported exception, file not found exception must be caught or thrown. Could just say throws exception, which is a big problem here. I spelled it wrong. Oh, import. Notice it's not in the java.lang like those ones we looked at the first time. It's not in the Java language, it's in the java.io. So we could put it here. Throws file not found exception. Notice that went away. I've seen a lot of people write code like this. Personally, I think that one is very problematic. You may see a problem with that. The syntax is fine. Logically, what we're doing, right? This goes back, throws goes back to the caller. Who's the caller on our main method? I assume the silent means y'all get the point, right? The Java virtual machine. And the operating system calls that. We have no control over anything before the main method. So throwing an exception back to a place where we have no control, I've seen a lot of people write their code that way, and that just really strikes me as bad, as something bad to do, because we're just handing the problem off, right? That's like, you deal with it, and we're not even going to address it anymore. That's just bad form altogether. So we can throw stuff back, but we can't really. If we throw it back beyond the main, then we've completely lost control of it. The Java virtual machine is just going to crash when that happens. It's going to shut down our program, but not shut down gracefully. So it's going to sit there and keep running with RAM clogged up with whatever data we were using, and no way to get back in and start and adjust it until the machine restarts. So you will see lots of people that do that, but don't throw stuff beyond where you can deal with it. Only pass it back, throw it back to yourself. Maybe think of it that way, or throw it back to a team member or something. Don't go beyond the main method, which means we want to put this in a try catch block. So try to create a new print writer object. And if that doesn't work, then we can catch a file not found, etc. Sounds like a good name for that. Again, I'm going to do the cop out thing, and we'll just spit out a message. At least not spit out the stack trace. I guess that is a little bit better than what would happen, but as programmers, it would be much more useful for us to see the stack trace. If something goes wrong, we need to know what went wrong so we can fix it. The file's not there. Or we don't have access. It's actually probably the latter, because obviously this is a thing for writing files, so it will create the file if it's not there. So the problem would have to be that we don't have access to write the file, despite the name file not found. I guess file not found would definitely be accurate for reading it, but we don't read with a print writer. So then we can say, actually, I probably shouldn't call that PW. Let's call that writer. There we go. That way I'm actually following that those naming conventions that I've talked about repeatedly, and we'll put a comment in the grade book if you don't following your homework. You should probably do that in class examples. So our writer object has the same methods that we know from system.out. We can say writer dot append, check error, close, format. Here they are. Print, print F, print line. Those are the three we're probably going to use, right? So writer dot print line or ln, same thing we've been using, and we'll just print that string. Which that one's not naming conventions either. What else do we need to do? Everybody should know this. We finish. What do we do when we finish writing to the file? Looks like you have something in mind, Larissa.
I thought that's what it was, but you have your, like, it's ending.
SDEV break.
Yeah, I was gonna say that, but it's
So
the ending.
let me make another text file. Get another line for the code. Right. Another line for the code goes right here. Well, I end up doing this. Anybody ever done stuff like that? Start typing in the wrong spot, your cursor's not in the spot you thought it was. We're humans, we'll notice it, we're intelligent. But a computer will never notice that. So the most critical thing, probably the most important thing to do when you're working with files is you have to remember to close them. This, well, like this example. Thought I was typing here, but I was in just a completely different file altogether. As a human, I'll notice that pretty quickly. Discard that, don't need to save it. Leave that. Yes. But a computer is not intelligent. It will not know that it is working in the wrong spot. So if it's in the wrong spot, it's just going to keep on working there, and that can be very, very disastrous. There are actually a lot of things in the operating system that protect from it. Let me leave that alone now. I'm going to forget to close the file and run this. Successful. And where that puts it, if we go to the NetBeans projects, this is where it was, yeah. So notice it right here at the top. It created it, but it's blank. That is protection layer that is there for the operating system. When software writes a file, it does not show up in the file. It will create the file, but nothing will show up. So if it creates the file, but it's just blank, then that means you forgot to close your file. When we close the file and run the same thing, nothing to see here. If we go over here, we see now it says 1 kilobyte, which is the smallest Windows Explorer will mark. That has to be less. That is way less than a kilobyte. But it has the smallest size that it would mark, and we can see that string shows up. So if it creates your file and it's blank, that means you forgot to close it, and that is absolutely critical. Because a computer will never realize that it is working in the wrong spot. So we can see that worked, and there was no output from it, right? Nothing comes back, so now let's read that file. And these are the two we're going to use most often in class because they're quick and easy. And we can read the same way we've been doing since the beginning. A scanner is for reading things. It doesn't care where that Unicode is coming from. The scanner is just going to process the Unicode that comes in. So if we have a text file, or actually it doesn't even care if it's Unicode. A scanner is going to just process whatever bits come in. It's going to try to process them as Unicode. So if we have a data file, the scanner is going to probably glitch out and give us nonsense. Because it's going to grab whatever bits are there in 16-bit chunks. And be like, okay, this is Unicode. Spit a bunch of characters out on the screen. But so it really wants to grab Unicode. So a scanner, and when you look up reference material and stuff, once again, they're going to call all of their scanners input, which I personally don't like to do because that gets confusing because it hasn't shown up in class yet, but usually we have more than one scanner going. Or a scanner for well, from this point on, we might need a scanner for the keyboard and a scanner from the file, and we don't want to mix and match them, so we might as well just create two different ones. That's the whole point of object-oriented programming, right? We haven't pulled up Carl or Dave yet. We might pull up some voice stuff. And obviously with the text to speech, we can also pick up from the microphone. We're not going to do that in class. It's there's not a simplified library to do that in Java, but there is a library to do that in Java. So yeah, we won't see it in class, but again, we could process that with a scanner. There are much greater objects for that, but in that case, we might have the microphone, the keyboard, a scanner watching what our mouse is doing. There's better objects for it, just like with the microphone. There's a better object, but a scanner just scans inputs. It'll work for all our inputs. So when reading and writing text files in the class, where we're under tight time constraints, we can just do a new scanner from the imports, and the message should say that there's no suitable constructor. Right? We saw in object-oriented programming overloading constructors. There's lots and lots of constructors for scanners. It ran out of room to show us the list of options of constructors for scanners, but there is not an empty one. There is no empty one because a scanner has to be scanning something. In this case, we want to scan a file, so I'll scan that file. And now we get that same message we saw earlier. Like, oh, you want to scan a file, the compiler can't tell whether that file is there or not. A compiler only knows how to look at Java code. It has no idea how to check what's in the hard drive. We can only figure out at runtime when the file is either there or not there. So same try catch block. So try. And it should probably be a file not found exception, but I'm just going to do a regular exception. We'll try to read the file with the scanner. I don't know what to do. There's file in that location. Okay. This is why I don't like messages. This is what the message says, right? I don't know what to do, but if we're Java programmers, we should know what to do. Can't find the file, there's got to be something we can do, some sort of fallback. But we're under too tight of time constraints to really dive in and study that in depth here. We just need to know the syntax. So printing out messages will work. But and hopefully this code will never run. Right? We desperately hope that this catch block never runs. But notice how it accepted that. Because a file not found exception is a child of exception. It's several layers down. I want to close that picture. That picture we were looking at in the book a moment ago, file not found, was on that list. And it was at least 2 layers to the right of exception, which with inheritance means that it is a file not found is a type of exception. So polymorphism works that way. It wouldn't go the other way. We couldn't catch a generic exception with a file not found exception. Remember, polymorphism only goes one way, the direction the arrows point when we see inheritance. And now you all know what to do with the scanner, right? There's a couple ways. Personally, what I like, while true, we need a string. I'll create a string, new string called stuff. File, stick with the proper naming conventions, which is this one is just a new blank string, nothing in it. Then stuff from file, and control space is the predictive text, which it was obvious what I was typing there, so just throw out the variable. Then instead of the whole list, stuff from file is assigned the from file scanner dot next. Sure, next to work. You all know all that, right? And I like this. Back to that thing I was talking about earlier with exception handling, we can do it with as small as 1 bit. While true is in Java, it's a C family, so it is 1 bit true and 1 bit false. 1 bit for each one, so that's a 1 bit condition. And eventually that's not going to be true anymore, right? And when it's not true, we will know from the very first bit that that is no longer true, and it's going to kick us out of kick us out of that block. That's the way I like to do it. There's an alternative way. a. I already commented that out. While the scanner, so from file scanner dot has next, it has the thing we can check, which obviously a method built into an object is a lot more than one bit. So that's why I like that one, because less processing and thinking about optimization stuff, because I first learned the program a long time ago, like when RAM was a very, very precious commodity. At the time, like the first time I saw a spreadsheet, it only went up to cell P16. It didn't even go all the way through the alphabet. That's 256 cells, 16 by 16 grid. You can do a lot in 256 cells. People often look surprised when I mention that, and like point out, like we spread things out. But how many times have you put stuff? How many times have you used more than 256 cells in one spreadsheet? Usually, there's quite a bit there, but RAM was a very, very precious commodity back then, so we definitely didn't want to waste it. That's why I like the other one. But we have plenty enough RAM to use the object-oriented stuff without much concern. So this is I guess this is a little bit cleaner as far as self-documenting code as well, right? And then we would do the same thing. That string is going to be whatever. If it has a next thing, then it's going to be whatever's next. And we have a whole bunch of the next. I can put it here. So like from file dot, you see it has next, but we can get into the specific ones: big decimal, big integer, next boolean, next byte, next double, next int, next line, next long. So all of the specific things we have in that scanner, we can ask for the next one of those, and we don't necessarily have to just be looking for the generic next. Either one of those works. If we haven't talked about it, and that means control slash, I keep doing that and probably haven't, I'm not sure if I mentioned it or not. Highlight the code and then control slash is comment and uncomment the whole thing as a block. Be careful though that you don't go too far right here. Like here, 3 lines are commented. So if I highlight 4 lines and hit control slash, it comments again. Because this line was uncommented, so it thinks it needs that doubly commented. It thinks there was an uncommented line in there, so it thinks it needed commented. So when you uncomment, be careful not to get any extra. Oh, I guess then we can print that out, right? Then we'll print to the console the stuff from the file. Why is that unreadable?
Chris.
Oh. No problem. Yeah, I just showed 2 ways to do this. This is my preference. I just do an infinite loop.
Okay.
You can do it as small as 1 bit, but a scanner object does has next and has a whole bunch of booleans to check if there's more stuff. It's that's all we covered while you're on. Which using the while true method is going to kick us out of that block. So in that case, I would need to move the print statement way down here. But if I use this one, then it's fine, because when we get to the end of the while loop, we just jump out of the while loop. We don't jump out of the whole try catch. For the purposes of when this goes on GitHub, I'm going to leave the one I like on there, which means I'll need to move this down to like the finally. But we have to be careful when we create the data to do it that way. I need to do the actual creation before the try catch block. Does everybody see why I had to move that? Hopefully that makes sense. And a quick pass at how there's more than one way to do these things. Right now, notice we hit an exception. I don't know what to do. There's no file in that location. And then it printed the word file. Well, I was expecting it to run. String file 1.txt is there. We use the same file to do that as this. Does anybody see an error in there anywhere? Sometimes I throw errors on accident, on purpose. I think y'all know that. This one was on accident. And it did actually work. What does this do right here? It grabs up to the next delimiter. So like a space, a comma, a whole bunch of things count as delimiters, line feeds. Goes up to the next delimiter and assigns that to stuff from file. Comes back around the while loop, goes up to the next delimiter and assigns that to stuff from file. Which looks in on faces of people in the classroom. There's a problem there, right?
Keep going.
Because it keeps replacing it. So should probably do the concatenate. I like to call them reassignment operators. Usually textbooks don't even want to call them assignment operators, but I have seen textbooks that use like I do, because we can't do an initial assignment that way. All we can do is reassign stuff. We should probably be doing this, and then we'll rerun it. And see, it kind of worked, except we lost it was using the space for delimiter, so all the spaces went away. We're gonna watch things like that. And then the other thing, notice when we do it this way, we don't need the catch block. So in this case, the exception is not a problem. This is actually what we would call null terminated. It's just manually coded in. When we get to linked list and data structures next week, we'll do that. We know where the end of the list is because there's no other data there. When we get to just the empty thing, get to the empty pointer, we know we've reached the end of the list. The same thing here. When we get to just an empty thing, we know we've reached the end of the file. So in that case, this is no longer true and it kicks us out of there. So in that case, the exception isn't a problem because we knew that was going to happen. I chose to use the infinite while loop inside the try catch block because now we can process the end of that file with only 2 bits. One to kick us out of the try block, and the exception block doesn't handle anything. But yeah, we can handle the end of this with only 2 bits because we kick out of here and there's nothing in the except block, so we jump into the final block. So less stuff going on there. And it's really, really bad form. I know it's really, really bad form, but my Java code looks like this all the time. The catch block is just I only tend to use try catch blocks when it forces me to, when the compiler forces me to. So the catch block is empty because I prefer to handle them manually if I'm expecting things. And that's because of learning to code in languages before try catch blocks were a thing. Or like they're not always reliable. When I was learning the language R, it might have been it has definitely been updated since then. But when I was learning that language, an error message just spit out binary code. There was not a stack trace. There was not anything human readable. If it hit a problem, it just spit out whatever code was in the CPU at that moment. Whatever code it was trying to execute just spit out to the screen. So that's how we could tell that we hit an exception. Is a whole bunch of binary code just spit the screen. We had no idea what it was. So that, and then doing stuff on computers way back in the 80s before try catch blocks were a thing, or if they existed in C++ back then, I didn't know about them. So learning it that way, I learned to deal with them separately. So my catch blocks pretty much always look like that because that's when it's done. I've actually had things where my catch block, I might leave off the finally and do the finally part in the catch block because I know when it's going to kick out of the try. But that is really bad form, and I have had lots and lots of practice handling exceptions in ways other than the try catch blocks. Like decades of practice at that. So I would not recommend it because it is definitely a lot easier. There's good reasons why they try to put that in every language. Any questions there? Does that make sense? Not our only way we can read from files. Let's make our own data. We have our own object, new Java class. I don't know my data. Seems like a good name for it. Anything fancy here? Well, let's just put some random data in here. So private integer, my number. Private string, my words. Private Boolean, my truth. Those things seem to flow nicely. Need some constructors, right? So alt insert constructor, we'll do an empty one. Alt insert a constructor, I'll do a full one, and that's probably good for now. Select all of them, generate that. Alt insert all our getters and setters. Alt insert and maybe toString. There we go. So we've got all that, and we have the toString representation. So seems like I should be able to go to a file. If we write it to the file this way, that's going to be hard to parse back out though, right? So I don't really want to write that string. I'm going to take all that out. And here's an instance of my object because I don't want to write it that way because that would be hard to parse back out. It looks nice when we spit it out to the console or if we're going to read it from the text function. But probably not so nice for bringing it back into code. That nice looking string is hard to parse through. We'd be better just to run all of our getters and print each data point to a different line. So if we want to write this to a file, we do have to make a slight adjustment. And this is where streams start to come in. Well, I'm doing it as a stream because print writer, that nice easy way, well, that has the same stuff as the print line, right? So if we try to do that, then we're going to call the toString method, which isn't what we want. Have this mean all of that data is stored somewhere in RAM. And when we write that to the file, we're gonna store it, and when we read it back from the file, we're gonna put it in the same type of object, right? And that's the object that goes with our software, so when we read it back from the file, we're gonna put it in the same thing. We don't, it's a bunch of extra steps to put it in a string and text file format and then parse it back out. So this is a spot where streams can come in. Let's create an instance of that. So on my data object, I don't know, data is new my data. What do we put in there? Number 34. I'll put the same thing. I don't know why I was thinking 34. Let me change that to 44, 45. That number's on my mind. 45 and true. 45 isn't explicitly false, so some representation of that. Right? We have our data, just a very generic example there. We're going to work with a file, so we know we need a file object. A file. Do this as an output stream. Streams give us more control. That's basically what it is. Think about streaming services. It's control over the data, how it comes across the network and what's coming. And we aren't going to see that control in the classroom, but streams give us more control about how we write a file. So this is going to be our stream file. That's going to be a new file. Give it some sort of name. We saw it goes to the top level of the project. So if you have like a configuration file you want to add to your software, you probably put that at the top level of the project and you don't have to read stuff. Otherwise, remember that you're running the classes, so it would need to be relative to this address here, going to the build and the classes, because that's where the code's running from. But in general, it's probably best just use an absolute address if you can. Use a file explorer. Since most computers these days have Python and Java installed, in my own software, I pretty much always use the Python TK interface package, the TK enter file dialog, ask open box or ask open dialog or ask open save. Ask open dialog or ask save dialog. I almost always use those for Python. And then the output of that, I print back to the console, which in the case of running software, isn't going to be like the terminal in, it's not going to be the console in NetBeans, right? That's going to be like PowerShell. So I print a string back there, and then I read that string into the Java program. That's how I do it. Probably shouldn't show that in class because that's probably very bad form and not very secure. It's easy though, definitely easy. Just read the file with the Python thing because they have that really nice dialog box that's easy to use, already pre-built for open and save, the two we're going to use most often. Print, and then the result of that just prints, which goes back to the PowerShell, and then have your, and then pass it in as the args to your main. Is how I like to do that. But, for the purposes of class, let's go with a nice clean form and put it in our project. What's the name for this? This is my file. Dot. I'm put my initials. A file extension is arbitrary. We can make it whatever we want. I'm gonna do that. Instead of my initials, arbitrary. That's right. Arbitrary, yeah, 3 R's. So an arbitrary file extension, which I might have spelled wrong. But however you spell that word, hopefully y'all can sound out what I was trying to spell if I did spell it wrong. The file extension is arbitrary, it just tells the computer what to do with it. In the example on my other computer, I used SDR last year when I did that. And now we know from earlier that we need a try catch block. So I'll go ahead and write try catch some sort of exception. I have to give it a name, and I'm not going to do anything. I'm just going to ignore the exception. So we should probably have a file not found exception. Do something if we have that. Also in out exception. Actually, I should probably show you good form, right? There's two problems that could happen here. We could have a file not found exception, which we need to import. I spelled that wrong. Try to do stuff, and if not, we're gonna file exception. Okay. I don't know why I can't spell things correctly. Oh, there's no F on there. Why is there no F on there? Yeah, that'll be fixed in a moment. The other thing we could have is we could have an IO exception. IOE. Which I'm not gonna do anything for either one. We need to import this one. And right now they're underlined because the try block doesn't throw either one of those. Like there's no chance, the compiler's like, there's no chance either one of these things is gonna happen. When we put something in here, there will be. Yeah, that's the two things that could happen if we're trying to write to a file or read from a file. So we don't need to get to the third one. We know there's no chance. It has to be one of those two. The one we haven't seen yet, file output stream. I'll just call it FOS because that's a lot. Is a new file output stream. I hit control space. I was not pulling up the full predictive text. I was expecting it to show something, and a file output stream goes to a file. So we have that stream file we can send it to. Run our import. And this is sort of representative of data for our software, right? It's a very generic example, but when we write a piece of software, we're gonna have our main class. The main thing we're working with in that application. For our pizza ordering app, our main class was the order itself, right? Or the pie itself. We have that main class, so we want to write that object. So along with the file output stream, we also have a object output stream. OOS sounds like a good name for it. A new object output stream. And an object output stream, it needs to take in a file output stream. Right, the object breaks it down and breaks our data down into an object that can be streamed. And then we can feed that stream into the file output stream. And that's an example of string. We get layers and layers and layers of strings. So the order we break them down in makes a big difference. Import that, and then we can write stuff with it. So that OOS dot write object, and then the object is the data there. The one right up here. So we'll write that data. And then, well, whoops. Anytime we work with files and streams, we need to make sure we close them and close them in the opposite order of what you open them Notice I left some space there. Hopefully there's no surprises there, but somewhat new stuff, right? We get more control because we don't just throw our data straight to it. We control how we break it down by creating this object-oriented stream. So I'm gonna hit a copy here, paste this in, and this is gonna be a commented outline. Because something you will often see is then this was only used to pass into this, right? So we could pass that in as that stream, and then we can keep doing layers like that. Switch it to a buffered stream so that instead of writing the whole thing, or actually the buffered stream would go between the object and the file. So instead of writing the whole thing, we write it 1,000 bits at a time, 1,024 bits at a time. If we have like many gigabytes, we can send it in small chunks to make sure it works. That's how your video streaming works. Object-oriented stream to a buffered output stream to a file output stream, and then that file output, instead of going to a file, heads to the network card, heads across the network. And the file is on the other side of the net, on the other side of the internet. So you will often see them listed out like that. But again, and then in that case, closed from the outside in, right? So object output stream, then the thing that goes in there. And then if there's many layers of it, the thing that goes in there. So the outside in, or if you split it up amongst different lines to make it nice and readable from the reverse order. Well, because if you close the file output stream while the object output stream is still running, then there's a problem because an object output stream can't work without a file output stream. Hopefully that makes sense. Just close them in the opposite order you open them in. Otherwise, hopefully the syntax there all makes sense. Oh yeah, we never went back and added spaces. Everybody knows how to add spaces back in, right? Just simple concatenation. So nothing fancy there. Hopefully no surprises, but a new syntax and a step forward in writing files because we actually take control over how it's going to be written. We have lots and lots of options. I guess we need to read this. So we'll need an object to put it in. Well, it goes in the opposite order. We had a file output stream fed into an object output stream. We also have input streams. So we need a try catch block. There's three things that could go wrong here. Because we're gonna do a file input stream. File input stream FIS this time, and I'm gonna finish that out. This way it stops underlining this stuff. So we could have a file not found or an IO exception. But this is an input stream going to, so we're also going to have an object input stream that'll work with it. I'll call it OIS. That'll work with that the same way the output streams work together. Hopefully y'all can probably take that and run with it. And then that's going to run into that's going to load our data back in. So in this case, we could also have a class not found exception. CMFE. Which again, I'm not really going to deal with, just list them out there. Normally, there would probably be, in real situation, there would be more code in those catch blocks than in the try block because we want to fix the problem. We don't want the end user to ever know that something went wrong with the software. We want the software to be self-repairing. And that takes a lot more time than we have in the classroom. Even when they're 16-week classes, we couldn't fit that. So should be no surprises on what goes here, right? That is assigned a new file input stream. which takes in a file object. Which that's why I created that outside of the try block so we could use it in the other one. It'd probably be better for him to create that inside of the try block. But for our example, I want to use the same file, so I created it outside of the block so we could use it again down here. And our object input stream is assigned a new object input stream that takes in that file input stream. And once we have that, we need to put in an object my data, file data this time is going to be that object input stream dot read object. And notice that the method that's built in is read object. There's not a read my data built in to that because they had no idea we were going to make that class this evening, right? So this is one that you always have to do the casting. Cast that into my data object, which shouldn't be any problem because we know it's there. And if it is a problem, we are in a try catch block, so we should probably catch that exception and correct it down here. But that part's straightforward logically, just time consuming to think about everything. And then once again, close stuff in the opposite order. So OIS was the last thing open, so close that first. And then close the FIS. Oh, I guess we should probably print that or something too, right? Okay, I haven't run this yet because there should be a problem. There was some talk about taking that out, but I don't think they have. I don't think they went with that. There's actually something else we should do before writing it to. I should put an exception here. Itch, exception E, print out, couldn't write to a file because there's still another step, but I want to see this error. Oh, I should probably E dot get message. I think that's what shows the error we get back from the Java virtual machine. Instead of the stack trace, which shows the stack trace is the last few lines that ran. There should be an error there. There was talk about fixing that, but last I heard they decided not to, so let's see this. Here's a string to write to a file. Then all of this ran. It didn't catch either one of those exceptions. Nothing happened afterwards. Did we get a file? Oh, it did. Right there. Okay, I was not expecting that to actually work. They took something out. I don't know exactly how much it changed. At least all the way up to Java 17, so you might still encounter this. That's still a common one. If we wanted to write it to a file, we had to implement the serializable interface. So they took it out, but it hasn't been very long since they took it out, so you will probably still encounter it. So just remember that as a rule of thumb. A rule of thumb. So I'm on Java 20, so it was removed by Java 20, but we should implement this serializable interface in order to make that other stuff work. Why did this line not work? Maybe that didn't actually work. It wrote the file. Oh, yeah. Oh. Sorry, that was silly of me. It wrote the file, but it didn't read the file. That should be a variable, not a string. I didn't mean to explicitly put that word there. Oh, okay. So it didn't read the file that time, so I guess we do still have to do it, but apparently we don't have to do it for writing, just for reading. So I'm gonna take that interface out. It's public class my data. No special restrictions on what it means to be my data, no rules put into an interface. So if we run this, notice there's no output from that object input string. So it kicked out of there somewhere along the way. But if we come over here and implements serializable, so that's what I thought. They did not remove that yet, but it did write the file. So we don't have to have that to write our data, but we did not read it back in. But when we put that in there, then we get that toString method from our object. So it did actually read it back in. I guess we could do one of the getters, right? Plus if plus data dot what getters get my stuff. Run that, and we can see that getter ran as well. So in order to read it, you have to implement the serializable interface. So we have string, and that gives us a lot more control over things. You'll want to look at stuff. I thought it was going to be finished about 5 minutes ago. File output stream. Java. We check the official documentation here. You see, file output stream is just a child of output stream. So if we come up here, we can see streams are closable, flushable, and auto-closable, close themselves. We can shut it down when we're finished, or if something goes wrong along the way, we can carefully shut it down, or we can empty it when we're done. And notice we have a bunch of subclasses: byte array, output stream, where we're moving things a byte at a time. Or stream. This one itself is abstract. Y'all know what abstract means, right? So you want to look through here and kind of click on these. File output stream, filter output stream. These are nice. Filter output stream is we can add some filtering in along the way. Okay, maybe we don't want any words. We only want the numbers that are in that file. I guess that's kind of like the scanner next int instead of just next, and knowing that we only type and hoping the user only typed an integer in there. Some sort of filtering, but then filter has a bunch of very powerful ones. Child class of that, we have buffered output stream, checked output stream, cipher output stream, so encrypting the data, just a data output stream. Deflators and inflators, like they sound, we can. Some of the stuff is obvious, so there's no need to transfer it. We don't need to waste bandwidth on our network transferring the obvious parts that the CPU can easily recreate on the other side. If our class has data fields like size is small and color is red, and then another data field called description, which just says small and red, we don't need that description. We don't need to waste space on that description data field because we can easily recreate that one. There's more to deflators and inflators. We can also make it bigger to transfer for the output stream. And we have input streams on all these as well. But you'll want to go through these. A digest output stream updates the associated message digest with the bits going through the stream. a little complicated. We sent extra data with it. Gets into the OSI model. But you can see there's lots and lots of control over how we do these. Same thing with input streams. Piped output stream, pipe is like the pipe symbol, the vertical bar right above the enter key and keyboard. Piping is the output of one function becomes the input of another function. This is piping, right? The output of the new file output stream becomes the input of the new object output stream. But normally when we refer to piping, we're talking about shortcuts to do that instead of piping the whole thing up like this. This is what we want. That's what pipe means. But you can see lots and lots and lots of things. Make sure you check the documentation for the different types of streams. As far as us in class, a print writer and scanner will be fine to get you through class. And a lot easier to work with because we've been working with scanners and system.out since day one. And print writer has the exact same things as system.out. So mostly be aware of the other streams. Make sure you take a look at those. Anybody have any questions about stuff from this evening? We finished about 10 minutes ago. So Liz is already headed out the door.
No, I just know I'm packing up so I don't forget anything. Make sure I got everything that I need.
Not lose your mouse again.
Yeah, not lose my mouse again.
Oh, yes. Yes, that
I
does.
already put that away.
All right, that was at least 5 seconds. That's plenty of time for those on Zoom call to reach over and hit the unmute button if you have questions. If you have any, let me know. Otherwise, I'll see you on Thursday and we're gonna get started into data. It's gonna go quick with the Spring Boot. REST APIs are really, really easy. You won't work with all video tutorials, so that's we're going quickly going. And then we're going to, instead of files, we're going to use a proper MySQL database to work with. So I will see you all on Thursday for that. Have a good one.